So this is the Physical Science Section 7.4 lesson video, and as always, if you like my videos all in one spot, then just subscribe to my channel. So we're going to talk about reaction rates. So reaction rate is the rate at which reactants change into products over time. So how fast are we making products? Reaction rates tell how fast a reaction is going. So for example, these two reactions are the same reaction, but if you look, you see a lot more bubbling in this reaction. So this one is taking place faster than this one. So if they're the same reaction, how is it possible this one's happening at a faster rate? Well, we'll talk about how you can change the rate of the reactions. So factors that affect reaction rates include temperature, surface area, concentration, stirring, and catalysts. So those are 5 ways that we can increase or decrease, depending on what we do, the rate of the reaction. Is temperature, surface area, concentration, stirring, and catalysts. So chemical reactions are based on the collisions of particles. So the more collisions and the faster they occur, the faster the reaction can occur. So temperature, generally an increase in temperature will increase the reaction rate, while a decrease in temperature will decrease the reaction rate. Increasing the temperature of a substance causes its particles to move faster, which causes more collisions. So in a cold substance, the particles are moving very slowly. In a hot substance, they're moving faster, which means they can collide more often and react faster. So then notice it says in general, because there are some reactions where maybe we want colder temperatures, but in general, the hotter it is, the faster the reaction occurs. Surface area. An increase in surface area increases the exposure of reactants to one another. The greater this exposure, the more collisions there are that involve reacting particles. So when a reaction is occurring, if you have a big chunk of something, the reaction can only occur at the surface. So right now, these green atoms on the outside, those are the only ones that can react with the red. However, if we crush this up and break it into smaller particles, which means more surface area, then notice the red particles can get to almost all of the green particles at the same time. Okay, so smaller surface area and particle size go hand in hand. The smaller the particle size, the larger the surface area, and that can increase how fast a reaction occurs. So that's why we crush things a lot and use lots of powders and tiny crystals in chemistry instead of big chunks, because we want the reaction to occur faster. Stirring. Stirring the reactants will generally increase the reaction rate. Stirring causes the reactants to combine quickly, which causes more collisions. So if I dump a solid in a liquid and I want it to react, the solid is going to settle at the bottom, and so only the liquid that's right around the solid at the bottom can react with it. However, if I stir it up, that disperses the solid throughout the liquid, and so more of the liquid can start reacting with the solid. So for stirring, we disperse the particles so that they can collide more. Concentration. Concentration refers to the number of particles in a given volume. Generally, reaction rate increases as concentration increases. The more particles that are present in a given volume, the more opportunities there are for collisions involving these particles. So for example, these pictures down here, I know it's kind of hard to see. We have a metal and an acid. This is a very dilute acid of low concentration. Here is a metal strip in acid of higher concentration. You can see the bubbling that's occurring. So this reaction is happening faster. That's the reason why I dilute acids a lot before we use them in the lab, is because a very high concentrated acid is going to be very corrosive very quickly with your skin. Whereas if I give you a lower concentration of acid, you'll start feeling the burn first, have time to wash it off, and usually there's not any damage yet. Catalysts. A catalyst is a substance that affects the reaction rate without being used up in the reaction. Since a catalyst is neither a reactant nor a product, it's written over the arrow. So here's a reaction. So in this case, because V2O5 is written above the arrow, it's a catalyst. So it's there to speed up the reaction, but it's not considered a reactant or a product. We're going to have V2O5 to start with. At the end of the reaction, we will still have V2O5. Sometimes a catalyst just provides a surface for the reactants to meet each other. I like to say it's like a dating website. Okay, so here we have our dating website, and we have the purple and this orange come, and they both join the dating website, and that allows them to meet. So they meet each other in real life, they get married and go on. Well, did they marry the website? No, they married each other. The website is still there, it's still the same website, but it just gave them a place to meet where maybe they wouldn't have met if they hadn't gone to that dating website. So sometimes, like I said, a catalyst just provides a place for the reactants to bond to each other. But the way a catalyst works is it changes the mechanism of the reaction. So it gives the reaction a different way to happen that requires less energy to get over. If you remember the little graphs we looked at for exothermic, endothermic, it has to get over the activation energy hump. It lowers the activation energy, which is the energy necessary for a reaction to occur. That's how all catalysts work, whether it's through providing a surface or something else. So, section assessment. What does a reaction rate tell you? It tells you how fast a reaction will occur. Or you can say it tells you how fast reactants are turning into products. Either one's fine. Number 2, what are 5 factors that affect reaction rate? Well, we just discussed them. There was concentration, stirring, temperature, catalyst, and surface area. I was about to say, I know there's a 5th one. Okay, so concentration, surface area, catalyst, I said concentration, stirring, and temperature. Hopefully I just said 5 different ones. I thought I might have repeated one. Oh well, you just saw them in the PowerPoint. Number 3, explain why reactions take place faster at higher temperatures. Well, remember, at higher temperatures, the particles are moving faster, so they can collide more often. Remember, collisions is what allows particles to react. If they don't collide, they can't react with one another. Number 4, how does a catalyst make a reaction go faster? It changes the mechanism, or you can say it lowers the activation energy for the reaction to occur. So it either changes the mechanism, or you can say it lowers the activation energy. That's the energy needed for a reaction to occur. All right, explain why hamburger meat lasts longer in the freezer than in the refrigerator. Well, in hamburger meat, we're trying to stop a reaction, and that is the decomposition of the meat, where it starts to mold and decompose. So why would we want it in the freezer instead of the refrigerator? Well, the freezer is colder, so it's going to slow that reaction down even more before it starts to spoil. Okay, so it lasts longer in the freezer because the colder temperature slows that decomposition reaction, or the spoiling reaction, whatever you want to write. So for number 6, my gosh, this is long. The reaction between magnesium and hydrochloric acid produces hydrogen. It would also produce magnesium chloride. I don't know why I don't have that on there. If you increase the concentration of HCl, the reaction takes place faster. Could HCl be considered a catalyst for this reaction? Well, magnesium is Mg, hydrochloric acid is HCl. If it's going to produce hydrogen, the hydrogen has to come from the HCl. So that means there won't be HCl at the end. It will have turned into hydrogen. Remember, a catalyst is present at the beginning and the end, unchanged. So it cannot be a catalyst. It would be a reactant in this case because it is going to help make the products. Remember, a catalyst is not a reactant or a product. And so since the hydrogen would have to come from the hydrochloric acid breaking apart, it would not be considered a catalyst. So hopefully now you understand a little bit more about how to speed up or slow down a reaction.